Okay, do we have one of the questions done?
Half.
Okay.
With an acceleration of 6, does that mean the v is 6?
The A is 6. Let's have our tutorial now anyway. We can give more time to practice these in later. What would you like to look at first? What questions were a problem for you that you want to see? What lesson is that called?
Velocity time graphs.
Yeah, okay. Velocity time graph. Which question?
4. Question
4.
I did so much with this one, I still got the wrong answer.
My answer could be wrong. I might have made a mistake.
I tried every way possible.
Yeah, my answer was very
Yeah.
Why did I give so many numbers? That's terrible, isn't it?
Yeah.
That's terrible. Why did I do
Well,
that?
it's just maybe a calculation mistake, but like, say it's
Yeah,
like
it could be my calculation mistake. Let's have a look. Did she get the right answer? No, it might be my mistake. Let's have a look. So, what's happening in the story? He starts at rest. Speed goes from 0 to 25. Yeah. Then it goes up to 30. Then up to 50. Then up to 60, 80, 100, 50, 0. Why did I do this to you guys? It was terribly mean of me. This is going, what's that now? 25, 30, 50, 60, 80, 100. So this one is at 25, 30, 50, 60, 80. These are at 100. This is at 50, and this is at 0. And I want the area. Do you know what, actually? Let's just do it in 2 parts. We have 1, 2, 3, 4, 5, 6, 7 triangles. 8? Oh, thank you. 8 triangles. So let's get all the triangles. Because what's nice here, I think, all my bases are the same, aren't they? So if it's half the base by the height, plus half the base by the height, if all the bases are the same, then I can take that out. So it would just be a half the base. What's the base here? 0.25 times the height. So what's the height of the first triangle? 25. The next triangle? 5. Next one? 20, 10, 20, 20, 50, 50. So it would be 0.125 times, alright, adding up time. 25 plus 5 plus 20 plus 10 plus 20 plus 20 plus 50 plus 50. 200. So that's equal to 25. Now that's only the triangles. We still have to add up these rectangles, don't we? But again, the base is the same, isn't it?
Yeah.
So I could just do my same trick. Base times height. So what's the first height? The first red rectangle? 25. The next one? 30.
50, 60, 80, 100, 50.
Okay. So let's see. 25, 30, 50, 60, 80, 150 times 0.25. Okay. And I should add that to my other answer of 25. So, please be right.
He is right.
Oh, but
Well,
yeah, I forgot to change the units. What the heck? That's what I must have mistyped that there. 12 million kilometers, is it?
Yeah.
No, no, that's not right.
No,
Yeah.
but the number, I mean, is very...
The number is correct, but the decimal point is totally off. So the answer is I forgot that these are all kilometers, not meters. So I should have multiplied them by 1,000. So my answer should be 1,000 times bigger. So it's this many meters. But if I divide by 1,000, I make it kilometers again. So the answer is 123.75 kilometers. Or if you want, 123.75,000 meters. Is that actually what I wrote? Except I wrote km, but I should have written m. I'll fix that in my reprint. Oh, so I'm surprised I got it right. Because when I did it last year, it was more painful than that. Okay, so is that okay? Yeah, what will we do next? Right. Which page? The same page. Yeah. 5 is good. Let's have a look at 5. A cyclist and a lorry are both stopped at red lights. Okay, so they're both stopped at red lights. The cyclist can accelerate at 5 and has a top speed of 10. The lorry can accelerate at 2. So I want to draw two pictures here. Here's the person on the bicycle, and here's the person in the lorry. Okay, and what's happening here? The person in the bicycle starts at rest, accelerates with 5 until she reaches her top speed of 10. So then she must travel at 10 meters per second. Okay, but the lorry can keep accelerating at 2. Yeah. Now, this here is velocity, and this one here is time. After how long and how far will the lorry overtake? So in other words, if you can picture this, okay, they both start together. The cyclist cycles off in front of the lorry. The lorry is still moving, but it's going slower, and it'll catch up and then overtake. And I'm interested in at this moment, when they're both together, yeah. So let me just imagine that happens here at time t. So at time t they both meet. What do we know about this time? Well, we know that, yeah, what's equal? The time is equal and the distance is equal. So that means that this area equals this area. Now, this has a slope of 5, and if the height is 10, maybe you could work out in your head quickly what the base must be. Yeah, it must be 2, because if the slope is 5, it means you go out 1, you go up 5, you go out 1, you go up 5. Okay, so that's a 2. So a half the base by the height plus the base by the height, because I'm looking at this rectangle and this triangle. So t minus 2, yeah? That must equal a half Now, yeah, we have to have the base by the height, but we don't know the height. We only know the slope. But think about it. If the base is t, what's the height? If the slope is 2. Can anyone see that? 2t, yeah, 2t. Because you go out 1, you go up 2. You go out t's, and you go up 2 t's. Yeah. So a half the base by the height. Right, let's see what we get here. We get 10 plus 10t minus 20 equals t squared. So we get t squared minus 10t plus 10, is that right? Equals 0. And calculator time, mode 53. First answer, 8.8. Second answer, 1.12. Why is that answer wrong? Why is 1.12 the wrong answer? Anybody?
Just more logical.
I have a why. T must be bigger than 2.
Yeah.
Because it has to be after this on the graph.
Exactly.
So T is 8.87 seconds. And once you know the T, you can know the S because you can get it from this graph. You can say it's a half, it's yeah, I'll just work it out. Oh goodness. A half the base by the height. So the S is 78.7. Because if I know the T, I can easily get this. Yeah, or you know, even I could use this formula. I could put the T in here, because that gave me the S for this. Or I could put the T in here, and that would give me the S here, but it's just supposed to be the same anyways. So T is 8.87, I have 8.16, close enough, and 66.2, that ain't right. 66. Am I mistaken my answer? I think I have a, 78 and 66 are quite different. I need to put a question mark beside this. I think my answer might be wrong. 78.7 meters is what I got when I calculated it. My time is right. Oh no, my time's not right. I said 8.87 and the time is 8.16. Maybe I typed something in wrong here. 2 times 2, a half time, that's right, yeah? That's right? That's right? That's right? That's right?
Your video?
My video is wrong! Disgraceful. Disgraceful. Alright. Oh, of course, because I wrote down the bottom here, check. Beside the video link. You see?
This
Check.
video link?
Yeah, you see at the bottom I wrote the word check. Meaning someone told me last year it was wrong and I didn't do anything about it yet. So, yeah, no, the video, I must have made a mistake in the video. So, yeah, I need to really emphasize fixing that. So
this is the correct answer.
Oh, this is right, yeah. It should be 8.87 seconds and 78.7 meters. So what mistake did I make in the video?
You put half times 2 times 5 for the first triangle.
Terrible, terrible. Alright, well that fixes it now. Yeah. Okay, what next now?
Page 11.
Yeah, what lesson is that called?
Revolving vector.
Yeah?
Question 7.
Yeah. Let's have a look at that. Okay, here's my block and wedge. Right, so the block slides, a block M2 slides down 45 M1 at a constant speed of 2. So it's going this way at 2. Yeah? And the wedge is moving away at a speed of 3. Okay? Now, I want to know what is the final magnitude and direction of the block of this guy. You see, he's not really moving at 2, because if he's on this that's moving at 3, you know, like imagine this was moving at 30, would this be moving right or left?
Left.
Yeah, in total it'd be left because it's on something going so fast to the left. So what we need to do is add these vectors together. Well, that's not actually so bad, because what I could do is I could resolve here, and then I could move this guy over here and add. So that's a 3 for sure. That guy, I want to resolve it into a 2. Now, we have to figure out this angle. What's this angle here? 45, because this is 45. So this is 2 cos 45, and this one here is 2 sin 45. 2 cos 45, this will be root 2. And 2 sin 45 will be root 2. Which is bigger, 3 or root 2? 3 is bigger. So it's going to head to the left. So it'll be going left, and it'll be going down. Okay? So it'll be going left with root 2 minus 3. That's negative, it's heading left. And it's going down with minus root 2. So if you want to draw the picture, what's root 2 minus 3 as a decimal?
Minus 1.5.
Yeah, so I'll just put in 1.5. And this is 1.41. Root 2. I'm not putting in the minus because I drew it pointing down. What's wrong? You look confused.
Yeah.
Is that okay? Is that okay? 1.5 left and 1.41 down. So I can get the magnitude by using Pythagoras. And I can get the angle here by using tan. So whatever this is will be the magnitude, and whatever this is will be the angle. Yeah? Is it okay? Now, do you see how it's pointing to the left? That means, now this is really hard, but if you can picture this moving like a movie, this is moving to the left and this is moving down. Okay? What if you could have a little laser and you could point the laser at the block, the light, the laser will look like it's going like this. Okay, because as this moves left and this moves right, this is moving down. But it's moving to the left faster than it's moving to the right. So, although this is sliding down, because this is going left, it'll look like it's going this way. Yeah, I really wish I had some animation of this, but I hope you can see that. Yeah, because we can see that by the vector here. It's pointing left and it's pointing down. So this is the total, the net vector, the final resultant. Okay, is that okay? What's next now?
I don't know how to do question 4.
On which one?
11, please, 11.
Yeah, what, the same page?
Yeah.
The girl is at the top of the slide as shown, ready to follow her brother as shown. She pushes off with a speed of 1 in the horizontal direction. The slide makes an angle of 45. With the help of the diagram resolved. Yeah, okay, so can I scroll down? See that? Yeah. So this is all I wanted. Here's the slide. Here she is. And her speed at the beginning, because the stair is flat, so she comes along this way with 1. meter per second. And I just want you to resolve in this direction and this direction. So what's this angle?
45.
45. So this would be 1 cos 45, and this would be 1 sin 45. And that's all.
Because they confused me when they said the x-axis and the y-axis. I got confused.
Yeah, what I was kind of getting you to think of, I want you to think of the slide as being like the x-axis, and this one being like the y-axis. So it's almost like in your head, you have to turn the picture.
Yeah, mine is like this. It's like when
You drew it like this?
yeah.
Yeah. Did you get the same answer?
Yeah.
Yeah. Okay. Whoa. Okay. Yeah. We got time. What else do we need to see? On which page? Same page.
I got the parameters, but I don't know why it goes to the horizontal.
Yeah. Okay. Let's see. What is the magnitude and direction of a particle which is traveling 5 centimeters horizontally and 12 vertically? So did you draw it this way? 5 horizontally and 12 vertically. Okay. And I think you're happy that the magnitude is 13 centimeters per second, and the direction would be tan inverse 12 over 5. What's that? 67.38.
37.38.
So that's east, 67.38 north.
Yeah.
Oh yeah. But another way you can say that is 67.38 to the horizontal, because you're measuring the angle up from this ground. Tell me what's confusing you.
The English.
The English. Yeah, to the horizontal means you measure the angle from the ground. From the ground up. Yeah. So like this one here, this would be 0 to the horizontal, and then 10 to the horizontal, 30 to the horizontal, 80 to the horizontal. Okay, yeah, good. The questions are okay. I know there's some problems, which is good.
But
Most of them are okay. Yeah. Have you done all the questions? Yeah? Okay. So what you can do for the next 10 minutes is to get a start on tonight's homework then of the kinematic equations. If you want to continue with that. I'll upload this tutorial now.